Hello, everyone. Thanks for joining to today's SAP community call on May 17th. Happy to have you all joining us. My name is Lena. I'm part of the SAP Community and Influence team, and I'm moderating our SAP community call today with the SAP HANA team. I'm glad to be joined by Jan Zwickel, who's our speaker for our call today, and Jörg Latza, my key enabler for the SAP HANA product team in the SAP community. The topic for today's call is calculation view modeling in SAP Business Application Studio update. And Jan is going to present to you all for the next 30 minutes with his presentation. Then we will have a very short Q&A because we want to ensure that everyone's questions are addressed, which is then followed by a 15-minute demo. And then we have yet again another Q&A. Questions can be addressed in the chat here on YouTube. I see that there is also already a lively chat. Say hi to us. Let us know from where you're tuning in. We'll have enough time towards the end to address your questions. And with that being said, I'll hand over to Jan to start with his presentation.
Thanks a lot, Lena, for introducing the session, and thanks all for joining the session. My name is Jan Zwickel. I'm from the SAP HANA product management team, in which I work on topics around analytics, and in particular, I'm focusing on calculation views. So this is also the topic of this session today, and I hope this is also what you are looking for, learning more about calculation views with focus on SAP HANA Cloud. Let me share my screen. So you should now see my screen. And as Lena said, I will give a kind of 30 minutes presentation, followed by a round of questions and answers, because I cannot at the same time talk and read your questions and answer your questions, at least not meaningfully. So I will do a short round after the presentation, after 30 minutes. Then I will jump over into a demo where I show what I presented, or at least parts of it. And then finally, there will be another round of questions if some are left. So let's see what's in store today. So first of all, I'd like to give an overview of HANA calculation view modeling. Then I want to talk about why do we do that. And I mean, the first step the overview should already give a motivation why we do it. But the second one then should also explain why we do it in a graphical way. Then I will talk about features of calculation view modeling, how you report on calculation views, talk about SAC connections to HANA Cloud so that you can report on your calculation views, and link to further resources. Before I get started, just let me point out that if you want to try that out yourself, there are options to use a free tier account or the old trial account if you want to get started and try out using SAP Business Application Studio with HANA Cloud and you creating calculation views. So I said I will start with an overview. So what you see here is I'm just wondering whether I have a laser pointer, but probably not. I hope you can see my mouse. So let's look at this should explain where calculation views are placed into the idea of working with analytics. In the lower part, you see a layer where you provide some data. So it's called data providing here. And the purpose here is that you somehow make available local or remote data. The objects that you can use for doing so are tables or SQL views or virtual tables. Now, where you create these objects, if you work in SAP HANA Cloud, then the idea would be that you create these objects either in Database Explorer or in Business Application Studio if you're working in SAP HANA Cloud. Now, I will make a distinction here between runtime objects and design time objects. Let me just explain first why is this important. The runtime object is just the database object as it is created. So if you create a table, for example, then you have a table in the database, and perhaps you created it with an SQL statement, and that's it. If you create a design time, then you don't create the table directly in the database, but you create you write a definition and you describe what the table should look like. If you deploy this table, then the database table is created, which means you have a description of the table before it's created. And this has now certain advantages because, for example, if you want to transport the object in another system, it's easier to transport the design time object, and you don't have to re-execute the SQL statement, which can be pretty cumbersome and lead also to some failures if you do it in a mass way. So by having a description in a design time file, you avoid these issues and you have a more consistent way of managing your lifecycle management. Having said so, if we talk about now the data provisioning, you can, for example, create a table directly in a database explorer. If you want to create just by an SQL statement, if you want to create the table via a design time file, then you could do that in Business Application Studio so that you have a description of the table and you can transport it easily. Especially if you're using SAP Business Application Studio, then you can use Git as a kind of industry standard for versioning your objects. Now, assuming you have somehow provided the data via SQL views, tables, or virtual tables, as said, then comes the layer where you can use calculation views to prepare your reporting. So the purpose here is that you pre-process the data and you do it on the fly. So it's not storing the data anymore. Calculation views are online objects. So it's like an SQL view in the end. You process the data while querying it. Now, the purpose here is that you get a high performance processing of data and that you can model the business requirements in your calculation views. The special thing about calculation views is that you do not only include business logic, but you also include database performance knowledge. So the more expertise you have about HANA performance, the better you can make use of calculation views as well, because you can put additional logic into it to benefit or leverage SAP HANA as good as possible from a performance perspective. Now, the idea here is that you do a pre-processing of a data, you prepare it, you put it into a meaningful way for the consumer. Let's say you have several tables and you know which tables you need to bring together to provide a meaningful information to the consumer. Then you can hide this complexity of bringing these tables together, doing joins, doing unions, doing pre-processing calculations, and so on in the calculation views with a good performance. But this is not all that you can do with the calculation views. It's not just putting the processing logic in it. You also get on top additional metadata. And this comes now if you create the calculation views as the design time objects, which you could do with Business Application Studio. On premise, you would do it with Web IDE. And if you deploy now these design times, then automatically reporting semantics will be deployed as well in the database. This will be stored in a schema called sysbi, and analytics tools can then evaluate this metadata from the schema and react to it. Why is that important? Imagine you want to have a prompt in your end user reporting. Now, how do you know that a prompt is required? Somewhere you need to get this information. And this is what is stored, for example, in the metadata. So if you define an input parameter in calculation views, then this information that a prompt is expected at that point is stored in the metadata, and the analytics tool can evaluate that. There's also a lot of other metadata stored so that the analytics tool can decide how to deal with it. For example, if you have a currency conversion or date, then this information is also stored. Sorry. So that the analytics tool can, for example, show a calendar picker or something like that. Just to be clear, you have here design time for the calculation views. The metadata is simply stored in tables and SQL views. If you access a HANA calculation view, you can do so via the SQL interface using SQL. So, yeah. Now, why are we talking about, or perhaps one thing that I would like to add here as well, because I mentioned here SAP Web IDE and Business Application Studio always. The point is that while SAP Web IDE is the development tool on premise, Business Application Studio is the development tool for SAP HANA Cloud. And the important point is that both are very similar in development concepts, which means if you develop a calculation view in Web IDE or in Business Application Studio, you can pretty easily reuse it in the other development environment. So the main point is that all have the same development concepts so that you can easily reuse it in the other tool. Now, why are we talking about graphical modeling? I mean, why not just SQL modeling or SQL statements? I think it becomes clear if you look, for example, on such a view here. I mean, even if you never used the calculation view before, it should immediately be clear to you, even if you don't know what it exactly means, that there are two input nodes. There is something going on here called a union and something like an aggregation. And this is exactly already a strength because it's much easier to communicate to someone else what you have developed if you have a visual representation of it. Imagine you have different stakeholders, and the stakeholders are not as good in SQL as the one who created a model, or they are not familiar with SQL at all. Then it's pretty difficult if you come with an SQL statement and try to explain what you're doing. Now, if you have something like a graphical representation, it's much easier to translate between different stakeholders. The more database experts and the more business users who understand better what they want and how the behavior should be, but cannot really understand directly what is going on in SQL statements. Also, it's not only about making it easier to communicate between different stakeholders, it's also easier to structure your development projects. Of course, you could also write an SQL statement that represents this behavior here. But as soon as you reuse the statement in another statement, or you stack another statement on top of that again, then it becomes much more difficult. And changing that then afterwards becomes even more complicated because you also have a lot of dependencies there. So it's also about structuring your development projects that you can create units that you can reuse and easily communicate with others and build on them again. Then, due to the close interaction between calculation views and HANA performance techniques, you can also achieve pretty good performance by that because you can make use and leverage HANA performance techniques. What are the features? Before I start talking about the features, let me just give some comments about the integration of calculation views with other options that you have with SAP HANA. First of all, we integrate with SQL script, for example, via table function nodes. So if you need SQL script, you can do so, and you can use it using table functions. Then we integrate with spatial scenarios. You can create SQL hierarchies from calculation views. And as I said before, you automatically get metadata that can be used then by reporting tools. And also we allow now, or we offer a Java API that allows you to programmatically create larger set of calculation views. That can become interesting if you have a lot of calculation view, or if you want to create a lot of calculation views that only differ in very small things like names for columns or perhaps different calculated columns. With the Java API, it's becoming much easier to maintain than a mass amount of calculation views. Now, what are the features? First of all, let's have a look at the optimization features that are specific to HANA. So first of all, I cannot go into all of the details here because of time, but let me just pick out one or two examples here. One thing is that you can control the push down of filters. This can be important because in some situations, we cannot automatically push down the filter. And this is due to semantic reasons. So for example, imagine you want to find the top 3 customers of US. Now, if you first filter for US and then you take the top 3 customers, you certainly will have customers, at least if there are more than 3 customers in US. If you do it the other way around and you first take the top customers, 3 customers, and then you filter for US, it could happen that you have no customer left because the top customers are all not from US. And that means there's a semantic difference whether you push down a filter and you evaluate do the filter first of selecting for a certain country, or whether you do it after the ranking. And in these situations, we cannot automatically push it down, the filter. But if you understand the semantics, then you can enforce the push down still by setting such a flag. And this is one of the generic or general themes of calculation views, that you have the option to add additional semantics that will then allow at optimization time to improve the optimizations and therefore lead to faster executions. So if you don't use this flag, then a filter will not be pushed down in semantic ambiguity. If there's no semantic ambiguity, then the filter will be pushed down anyway. Another option that you can use, for example, is around the topic of pruning. So for example, you can add additional semantic knowledge. If you know that for a certain query that goes for old data, that only one certain data source is relevant and the other data sources are not relevant of a union, then you can add this semantic information additionally. And because of this semantic information, then at the optimization time, it's easier to find a good solution and to avoid evaluating unnecessary data sources. So the general idea is you add additional information, and because of this additional semantic information, you can make better decisions what you can ignore in the model at runtime. This is called union pruning, where you, for example, say the source left is only filled by data from 2019, and the other data source is filled from newer data, and then depending on your query, at the execution time, only a certain source is accessed. This is similar or sounds similar to partition pruning, but it's different in a way that for partition pruning, you would need to have the tables partitioned according to your filter criteria. So you are much less flexible. Here you have the option to flexibly define what a data source does or contains without changing the partitioning of your table. For join pruning, this is also a technique where you can decide that certain joins don't need to be executed based on some additional information that you provide in the design time. So if you know exactly the relationship between 2 tables, how often the cardinality between the 2, then you can support join pruning, and at runtime, a lot of joins might not be executed because they are not really necessary. A general feature of calculation views is that we do column pruning, which is a very strong feature actually, that if you have a large view, for example, here you have all of these columns in your view, and it could be much larger, but then it would be difficult to display here. But at runtime, you only request billing status and net amount. Now, for calculation views, it means that all of the other columns don't need to be processed and they are pruned away, which is pretty strong because it means that you don't have to keep this data on a very high granular level, which has a lot of records then and consumes memory, but you can get rid of all of these columns very soon, and by this reduce resource consumption and also increase performance. And this is, for example, not possible with an SQL view in general, because if you have an aggregation, like for example, average or something like that, then even if you request only one column, then also the other columns need to be processed to fulfill the SQL expectation. So that's, for example, one difference then between calculation views and SQL views. Then we don't only support good integration with HANA performance techniques, but we also offer ways of analyzing what is going on in the model. So for example, here we have a performance analysis mode, and you get here some tips, like for example, that the join is placed on a calculated column, which is typically not so good, because it means if you join on a calculated column, the calculated column needs to be calculated first, which means also the optimizer has a lot of less options to optimize it because the sequence is already defined by this definition. So it's always good not to join on a calculated column if it can be avoided. This would be one performance tip. Here in the debug view mode, you see how an query is indeed then executed, what it means. And here's an example of the join pruning. So we have here join, we have two simple tables here. That could be large models that in itself, again, are stacked and so on. So that could be very large. The important point is you have two sources here. And based on the query, it is decided that you don't need to execute this join, and this data is still correct, even without executing this join, and therefore the join is pruned away, and you only get the you only process this data source. And this is shown here in the debug view mode by graying the second source out, which means for the current query that you execute in this debug view mode, this part would not be accessed or processed. Then we offer model health checks that give you also additional tips on how to improve your models. This is something where you call an SQL procedure and get more tips on your models. Then also we have several graphical illustrations of your data, which should give you an idea of how your data look like, whether you did the correct modeling and looks all like you expected. But this is of course not meant for reporting, but more for really getting insight into your data. Then we have features like getting a better overview of your model, doing a lineage analysis or impact analysis so that you see where your view is used in an impact analysis or what objects your view is using. At the moment, these lineage and impact analysis are only displaying objects within the same HDI container, but we will work on improving that soon. Then we also have an option called auto documentation, where you can get then automatically created some information about your models so that you have something to share if you want to document what is going on there. Then we have a close integration with various online analytic processing features. So for example, we support restricted columns, calculated columns, currency conversion, temporal joins, and so on. Another feature that's typical for calculation views are input parameters. So these are the kind of prompts that I mentioned before. Actually, there are two types of prompts. We have variables and input parameters. And the special thing about input parameters is that you can refer to them inside the model. So for example, you can have a prompt for a year, and in the model, you can decide that based on the input of the prompt, then you filter a value for the input parameter. So you can use this input parameter in expression in your model. Then we support hierarchies, as I said before. The ABAP kind of dealing with clients, the mandant field. We support analytic privileges, which is a pretty strong option if you want to define for individual users what records of a view they are allowed to see. So for example, in this example, if the user had exactly only this analytic privilege, then the user would only see data that has for the field country or the column country, the fixed value Germany. And other values would not be visible to this person. So you have a way of fine granular decide what someone is allowed to see using the analytic privileges on a record level. We also have an option on the column level where you can mask columns if they should not be visible to individual users. Then just very quickly, some recently added functions we offer now, just to give you an idea of what is going on currently. So we added a procedure that allows you to generate time data. Before, that was only possible via the graphical UI, but this gives you now a more flexible way of doing it in an automated way, perhaps by a scheduling mechanism, or also doing it in a system where you don't want to connect with the development environment. These time data are often used for example, determining the weekday of a certain date or getting an interval if you want to join between and want to list all the dates in between if you want to list all the days between certain dates so that you can join on them, or if you want to map between different date representations. We support keyboard shortcuts, which should make it easier for or faster if you are experienced to create your models and work with your models. We support the mapping of the input parameters also to remote views so that you can control also in a remote scenario and make sure that the filters are arriving in the target system. So if you have a view in SAP HANA Cloud and you're connecting to an on-premise system, then you can map this input parameter so that the value that is entered by the user will be used as a filter in the remote view as well. Then we have now an option to do a data preview also with other database users that should, for example, makes it easier to check how a view would look like for another user with a different authorization. And this is, we have also now session user masking, where you can now do the column masking based on a session user, which means now you can use masking, column masking, also in included calculation views. Before, this was hindered by the setting of using the invoking user, which led to the situation that column masking did only use the technical user if you had a stack scenario. Now you can also use the session user and therefore stack calculated masked columns also. And we have added, for example, functions like window functions, which are pretty powerful if you want to analyze data based on certain data partitions. For example, you want to have the top some top ranking of certain measures based on individual partitions, or you want to get a leg out from the record before. So if you want to make relationships or analysis across records and not only within a record. Now, reporting on calculation views, as I said, you can use SQL to report on them. And so there's not much to be said in the end. I mean, you have a calculation view, you execute the SQL statement on it, but the interesting part is the metadata. If you want to learn more about the metadata, perhaps you want to read out some of it, then there's a link to the documentation about the metadata that is written. And this is exactly how third-party analytics tools can connect to SAP HANA Cloud and report on calculation views. SAC has now also a live connection to SAP HANA Cloud, where you can choose SAP HANA Cloud as a data source, and then you don't need to do additional configurations, except if you want to use single sign-on. And this should make it pretty easy if you want to use SAC with SAP HANA Cloud and calculation views together. Now, the development environment. Let me spend at least a little bit of time on it. So historically, we started with SAP HANA Studio. This was an on-premise solution, and during our journey to our cloud solution, we developed a Web IDE, which is a browser-based tooling for developing calculation views. And for HANA Cloud, we then created a native cloud application, the Business Application Studio, where you can also create the calculation views. But as I said before, the important point is if you compare here the different properties, you see that they are both running on the same target or targeting the same runtime, and they use the same design time, HDI, and also as a versioning method, Git. And this makes these two tools very similar, which also means you can take projects from here and reuse them here and the other way around. Of course, there might be some feature differences because SAP HANA Cloud has faster developments receives features much faster than the on-premise release cycle. So there might be differences in features, but in principle, the projects can be reused in both directions. This is now a look from a different perspective. Just mentioning again, we had different development environments, and the idea of Business Application Studio is to integrate all of the demands into one tooling. It's a development tooling platform, so it's not only about calculation views. I mean, this is why I mentioned it here, because it also includes a calculation view modeler, but it's a development tooling platform where you can create your tables, virtual tables, and so on. The interesting thing is that it runs in a browser, which means you don't need a separate installation. And also you don't need to take care about the updates in your client tools of your clients. The deployment works via deployment infrastructure, HANA Deployment Infrastructure, HDI, and it's integrated with Git. Now, before I start with the demo, let me introduce some key concepts. The idea of HDI is that you have a pretty isolated container, which the idea is that you have, if you develop in a Business Application Studio and you create a project and you deploy it, then an HDI container is created. And this is an isolated environment, more or less, in which you as a developer work, which means if another developer also creates a project, even if it's the same project or the same named project, per default, it will go into another container, which means both developers can work on the same objects and they don't interfere with each other. Because if one developer changes an object, it's only done in its own container and the other developer works still on his or her own objects. If you want to synchronize different developments, then this is done via Git, where then the different developers agree on one version. But the general idea is that the HDI containers are a kind of isolation concept. And this is important because it makes it pretty flexible in using it in different environments. For example, if you want to use it in different systems. For things that you developed in development, you want to reuse in for example, quality and production. And by using HDI container concepts, it's easier to adapt it then to the new environment. This comes by having a clear interface to data from outside. And this is exactly what's shown here. So as long as you work on objects within your own container, you can simply refer to them and use them. And if you transport the container, all of that is still valid because you have all the data that you need in it. However, if you refer now to other data, for example, of an ABAP schema or whatever, then it's an external data that's not transported with your HDI container content, which means at that point, you have to make sure that some references to the external objects is still valid. And this is done by ensuring that you have for all objects that are from outside of your container, you have synonyms defined. And by having such a clear interface, it's much easier if you go into another system to make sure that the synonyms are still pointing to valid objects. So to make an example, if you have a calculation view and let's say you use a table 3 times, if you now move this calculation view in another system, it would mean if the table is named differently or perhaps it's in a different schema, you would have to rename the table in 3 different places in a calculation view. Now, by having the abstraction of a synonym, you only have to change it at one place, at the synonym definition place. And if this synonym points to a different schema or to a totally different named object, then this is all abstracted away and your model can stay as it is. The only important point is that the synonym is pointing to a valid object, and changing the synonym there are different techniques how to do that automatically, and there are different ways of achieving a lot of flexibility in referring to different objects depending on the different schemas. Talking quickly about some development concepts, and then I pause for the questions as promised before. One important concept is the Cloud Foundry space. Spaces are all over now, everywhere now, and so it's important to make sure which space we are talking about. Here it's about Cloud Foundry. So it's an environment in which the services run, and if you have a developer authorization for a Cloud Foundry space, it means you can use all services that are running in this space. Which means if you are a Business Application Studio developer, you have a development authorization for Cloud Foundry space, you can use all the services there, which also means you have access to all the data that these services provide, which means developers in the same space have the same authorizations. A service is what I just talked about. It runs in a space and it allows you, for example, to connect with your development project to other projects or to other schemas and access them. So the service can provide access to data. I talked about HDI containers. This is a virtual construct. And if you deploy an HDI container in Business Application Studio, automatically in the background, different schemas will be created that are per default named after your project name with some endings here. Then for each developer who's deploying, it's counted up so that every developer ends up in a different schema per default. And the naming convention is that if you have the underscore here and a number, then this is a schema where the deployed objects reside. The HDI, hash DI, has some procedures that can be used for deployment, and the HOO is just a technical user for the object owner, which is something like the sysrepo user in the repository, but local to your container, which means in the past you had a very powerful technical user sysrepo, which was required to grant that you grant privileges to this user if you wanted to create a calculation view on objects. Now this powerful user is not there anymore, which means that you can on a much more fine granular level decide what privileges a certain developer should have and on which objects the developer is allowed to create calculation views. The application user is also a logical concept, and perhaps I should say some words about why we have such logical concepts of object owner. As you see here, if I deploy a container, it's counted up, which means my schema is named differently, and also the object owner is a little bit named differently. This means now if I want to create to grant certain privileges to my object owner, I would have to, if I named the object owner directly, I would have to change it for every developer. And this is certainly not what you want. That developer one grants privileges to an object owner one, and the second one to object owner two, and so on. And therefore, there's an abstraction that we say object owner, and you grant to the object owner, and whoever the database user is at the runtime then doesn't matter. During deployment, it's taken care that the correct object owner of the project gets the privileges. That means the individual developers can use the same files or project definitions and still grant the privileges to their individual object owners of their individual projects. And a similar idea applies to the application user, which is also an abstraction for certain users that are created at runtime. So for example, here in a definition of an HDI service, you see the RT user here, which is used if you do, for example, a data preview on calculation views. And also here, you don't grant the privileges directly to this RT user, which could change over time, but you grant it to the logical application user. Synonyms are just descriptions of a name of the synonym and then to which object they point to. At least this is the simplest definition. There can be more complex or additional options here, which make it then more flexible to change the schema or object name. HTTP grants are files where you define now the privilege assignment. And this is what I talked about before, the object owner and application users. In an HTTP grants file, you use a service, here the UPS dev WS, and this service is used to grant the object owner, whoever database user that is in this project, the global role generic OO. The application user is granted this role, which means if you deploy this HTTP grants file afterwards, the object owner will have the privileges that are in this role, and the application user will have the privileges in this role, which means if you have a select with grant on an object in this role, then you can build calculation views on exactly these objects here. You can do data previews directly on these objects if you grant it also to the application user. So that can be useful if you also grant here select on the underlying objects. But just to reiterate it, if I have a role here, and in this role I have a select on object X with grant option, then afterwards, after building this HTTP grants file, I can report or create a calculation view on this object X. So you can create HV roles, but this is more of a detail how you can also create roles in your project. but that's less related to calculation views. And this is now the last slide before I start then the demo after the questioning. I talked about Cloud Foundry spaces. This is now another space, the development space. And here the idea is that in Business Application Studio, you create your own development environment, so to say, where you add certain extensions that you want to use. For example, someone wants to work with a Markdown editor, then you can add extensions. It's very similar to the concept of Visual Studio Code, where you can use these extensions then and say you enhance your environment with the things that you want. If you don't have any strong preferences at the beginning, it's certainly helpful if you just take a template, and if you want to do calculation view modeling, then select the template, SAP HANA native application, and then you get a lot of extensions already selected that are useful when you work with calculation view editor. And with that, I stop here with the presentation, and let's have a look at the questions. Lena,
Yes.
Are there questions that should be answered already?
There is a few questions, yes. Jörg was very busy with already answering.
Okay.
There is some that I would like to address, but I want to be mindful of the time for you to have 50 minutes for the demo. Because, as I said, all questions that we can't answer here in the call, we can definitely address in the SAP community. There is one that I would like to address for CV performance analysis. The question was, which tool is more preferred, or the most preferred one? Performance analysis mode, debug query, or SQL analyzer?
I mean, it depends on the question you are asking. The debug mode is something good if you want to understand which query is executed at which level of the model. So, for example, you have several nodes, and you have a query that asks for a certain column. The column is renamed, and how does the query look like then at a lower level? So it's understanding how a query looks like in the model, and perhaps also seeing what is pruned away, what is really executed, or, as I said, what is pruned away because it's not relevant for the query. This will not give you then very much insight into the performance itself, or why something might take a little bit longer. Then the next step would be, if this does not solve, I mean, you would, for example, find with this problems if something should be pruned, but it is not pruned because you see it's accessed. That's the first step that you could do there. Then, if you want to understand where time is spent, then the next step could be to do an explain plan of the SQL statement, where you then see what tables are accessed, how large are the tables, and some statistics estimations there. If also that does not solve the question that you are after, then the SQL analysis mode is a good way to digging deeper. So now you're getting deeper and deeper into the details, and there you would then see the individual execution parts, and could see also how long time is spent in each of the parts there. So this is then the most detailed analysis, and it's probably the one that you would need then at the very, if the others don't answer your questions. But I would not always start with the SQL analysis mode. I would first start with the easier ones that are there, checking the debug mode, then checking the explain plan, and only then look into the details. But it depends really on the question exactly that you want to have answered there. And of course, it's also a good idea to run the model health checks first. Perhaps they are always already pointing out some best practices, but they are not analyzing issues. They are more giving best practices. So if the question is about analyzing issues, it's probably in the end then either debug mode followed by SQL analysis,
Okay, that was a long question. I hope that got answered. Srikant, let us know. There is another question, but there's also 4 questions by JP. One that I would like to address, does the BTP HANA view have exceptional aggregation feature like SAP BW queries?
I mean, exceptional aggregation is something that includes a lot of parts. Let me say it like that. If you want, for example, to what is often meant with it is that you do a certain aggregation before another aggregation happens. And this is something where you could model that directly in the view. So for example, if you want to have first a certain aggregation level, and then you reduce the columns, and then you can aggregate again. So you have two different aggregations, and this is a kind of exception aggregation where you first have an aggregation, let's say on year, month, day, and then you have just an aggregation on year only. You can also model that in individual views. What is not there is that you say, I want to have an exception aggregation, and then it's automatically done. So you have to model that. Then there is the meaning of exception aggregation as soon as it's not a sum. And this, of course, you can do. I mean, you can do averages, you can do counts, and so on. So also this kind of exception aggregation is there. So in the end, I think the question boils down to what exactly is meant with the exception aggregation. In general, you can model it, but it's not like just a flag that you turn on. I know that in the old times, there was a flag where you could say, calculate before aggregation. But this flag is not there anymore because it's just obscure. I mean, if you do a calculation before aggregation by a flag, it's easily overlooked in the model. You can much cleaner model that now by having, for example, a node where you do the calculation. And on top of this node, you place an aggregation node. And this is now a clear indication of where the calculation is happening. You do the calculation first, and then you do the aggregation. And this is directly visible in the model. It's not anymore hidden behind a flag like aggregate before, calculate before aggregation or so. So you can achieve that. So in general, you can achieve these exception aggregations, but you have to model it yourself. It's not like simply putting a flag on it, but actually I think this is rather a feature in this situation, because the flag is rather hiding that there's something happening before the aggregation, and you can explicitly model it and show it visually that there's some calculation and there's then the aggregation afterwards. So I hope I touched now all meanings of exception aggregation. Perhaps there might be other ones, but I would suspect that also you can achieve by direct modeling that.
Thank you, Jan. One more question before I let you go and start your demo by Michael. Is it in the roadmap to allow single HDI object transport? At the moment, we can only transport the full HDI container via MTR file.
Yeah, MTR. I'm now not an expert. I'm not an expert for the plans there in the HDI part. Generally speaking, I mean, you could use Git, which is not a real transport then in that sense. You could create an MTAR just with a single file, which is probably also not that what you want. You could theoretically also use SQL procedures to deploy individual files. I'm not aware that there's a plan to automatically say create only an MTR file out of one single object. And I think that would be also dangerous in a certain sense, because you might lose all the dependencies that you need. I mean, it's not just enough to deploy a few. You also have to make sure that all the consumed objects are also then there in the right version, because let's say you added a column and you use this column in another view and you just deploy one single view, it would be a problem. So I think keeping the structure of the HDI container is probably in itself not a bad idea. I guess there's always a way around to create an MTAR only of one file, but that will not really then be probably a very good thing. I guess there might be a reason why you're asking that, and there's perhaps a specific situation. Perhaps this is something that's better than that we deal with if you write exactly why you are looking for that. If you write that in the chat, and then we can deal it offline. Whether there are some plans. I cannot really comment on HDI, but I would suspect that there's nothing planned in this direction because of the reasons that I just said.
Thank you, Jan. Then Michael, if you have a more specific question, I will in a second share the tag question tag link for SAP HANA in the chat. So please address that question in the SAP community so Jan and other experts can respond to it. And Jan, with that, I'll hand back over to you. 10 minutes left for your demo.
Okay, thanks. So what I wanted to do is, actually, I wanted to show you how to create a dev space. So this would be, you give a name, you take the template, and then you get all of these options here. For sake of time, I have already created that before. Now, this is just an empty space, and I'm starting it up now. And this is now the environment in which I can create projects. So the first thing that I do now is I start from a template that will then create a project for me and fill some default files in it and give me a structure for working on later. So it's taking a bit. Okay, but it's loading. So I take the SAP HANA project. I give it a name. I take just the default here. Now I have to log on with my Cloud Foundry account. And now I'm logged onto my Cloud Foundry account, and I'm only authorized to develop in one space. So this is automatically selected here. And if I create another project, the service will run in the space. So I click Finish, and this will now run then in the background. What will happen is that the HDI containers are created, that a service is created, and yeah, I mean, you can, for example, see here some files are already put into the project files, and the service is here created. And if I switch here over to the and reload it, the BTP cockpit, then I can also see that already the service is in the process of being created. So here now, because I create a project and I deploy it, I get a HDI service. It is of type HANA schemas and HDI containers, and it's running in my space. A different look that I can get here is if I press, for example, F1 and say Database Explorer. Now I'm switching over to the catalog view of it, where I see then the catalog objects. I'm here with my database user dbadmin connected to the system. And if I go here to the catalog view and I look, for example, for tables, I see here, first of all, the schemas that are there. And as you see here, already the HDI container schemas are created. Demo was the name, and so it's automatically created here, the 3 schemas that I talked before. At the moment, they are empty. And if I go back here now, the project has been created, so it's restarting the workspace. And I have here now my project. And I can create my objects here in this folder SRC. Let's create a very simple table, but first get some structure. I create a new folder, call it tables. I create another folder and call it CVs. And then for illustration, I show you, because there's a close integration with Linux also, I can also work here on the file system level if I prefer to do that. So I can, for example, say, go here and make a new folder, synonyms. And then you will see that it will also appear here. So I can work in both ways. I can create it here. I can create it with Linux, whatever I prefer to work on. Now let's create a table here quickly. The important point is the extension, because the extension tells what should happen with the file. So let's call it column table T1. It has a field nvar char and a field int. Now I deploy it, and everything is done, and the table exists. So if I go now, great. I'm wondering why Zoom is always overlaying so that I cannot select the tab. Okay. Okay, so if I go here now and I refresh that, I should see now the table that's created here. And you see here now it's the table T1. I mean, this is not very interesting. It's just an empty table. The other thing that I can do now here is I can create a calculation view. I could do it also with the extension. So I say .hb calculation view. Another option is that I go this way and say database artifact. Then I have a graphical way of doing it, or creating the file. I mean, in the end, it will be the same, whether I go with the extension here simply, or whether I select it here. It's just what is more comfortable to work with. So now the view is generated. It's generated here, so I can just drop it in my folder where I want to have it. And I can open it. Now I can add my table. So I click on the plus sign. I say, take my table. I select all the columns here and I deploy. And now I can do a data preview, which is pretty meaningless because the table is empty, so you will not see much. But I mean, the next step of the demo would be that I show how to access data that's not inside the container and make a calculation view on top of it. But I'm afraid that time is running out. I mean, should I continue with the demo still, or how should we do with it, Lena? What do you suggest?
Can we publish a blog post and do it there? So we need to be mindful of everyone's time and stick to the time frame. But that next step could be described in a blog post, Jan?
I mean, it's already described in a lot of blog posts, but we can link to it, yes.
Okay. Okay. Yes, we're. It's 5:30 CET at least. So I would like to thank everyone for all the questions that we had in the chat. There are some that have not been answered, but it's great. And I also already commented in the chat that you guys helped each other out. So thank you for that. That's exactly what the community is for. And the rest of the questions, we'll look forward to seeing them in the QA. I published the link. Thank you, Jan, for your time and for demoing and showing all those insights. It was very interesting. As we saw, there's a lot of questions, so everyone was interested. There's more SAP community calls coming up. Please check out those. We have another one with the SAP HANA team on Thursday. Yeah, thank you, Vitaly, for joining. Yeah, Jan, closing words from your end.
Thanks a lot for your interest, and looking forward to seeing you soon somewhere. Bye-bye.
Thank you, guys. Take care. Goodbye.